Morning dear students. Last class we discussed about determinants, about 8 to 9 properties of determinants, and using properties of determinants how to solve a determinant. So first let me ask a question. What is a determinant? Is it applicable for all matrices? Yes, very good. Determinant means you get a finite value, and determinant can be found out only from a square matrix. For rectangular matrices, we cannot find determinant. It is a definite value, whereas a matrix means it is an arrangement of data in terms of rows and columns. Now, today we are going to deal with minors and cofactors of a determinant. So, determinant means it is 2 by 2. Minors and cofactors of a determinant. So, you may be thinking, what is the use of finding of minors and cofactors? Later on, towards the end of the chapter, you can see that you may be solving a system of linear equations using matrices and determinants. So, for that application, you need minors and cofactors. First, let us consider an example of a 2 by 2 determinant. 2, 3, 1, 4. What are the minors? Minors are determined by M11. M11 means this 2. You eliminate the row that contains 2 and the column that contains 2. So, first row, first column. So, you are left with 4. M12. It is equal to, you eliminate first row, second column. So, 3, this one, it is equal to 1. M21, it is equal to, eliminate the row containing 1 and the column containing 1. It is equal to 3. And M22, it is equal to, eliminate the row containing 4 and the column containing 4, it is equal to 2. These are the minors. Now, from minors, you can obtain cofactors. What are the cofactors? Cofactors is denoted by, the notation A11, capital A11, A12, A21, A22, etc. Cofactors of A11 is equal to minus 1 raised to, what is the suffix over here? Suffix is 1 and 1. You write 1 plus 1 into M11. It is equal to minus 1 raised to 2. It is positive. M11 is 4. So, this is equal to 4. A12. It is equal to minus 1 raised to suffix 1 plus 2 into M12. That is equal to negative of, what is M12? Negative of 1, and that is equal to negative 1. Next one we have A21 is equal to minus 1 raised to 2 plus 1 into M21. 2 plus 1 is negative, that is negative of 2 plus 1 is equal to 3. So, that is equal to negative 3. And A22 is equal to minus 1 raised to 2 plus 2 into M22. M22 positive, and that is equal to 2, which is equal to 2. So, we can say that the minors are this one and cofactors are this one. From this, you get another thing, what is called as adjoint of A. ADJOINT, adjoint of the determinant A. Now, onwards it will be written as ADJ of A. It is equal to cofactor of A, the whole transpose. Cofactor of A, the whole transpose. Now, what are the cofactors is equal to? Cofactors 4, minus 1, minus 3 and 2. And its transpose. Now how do you get the transpose? You interchange the rows and columns, and that is equal to interchange rows and columns. 4 minus 1 minus 3 2. Adjoint of the matrix A is equal to, it is equal to this one. So from this one, I'll give you an easy method to find out the adjoint of a matrix for a 2 by 2 matrix or for a 2 by 2 determinant. From this two, you can see that, from these two, you can see that adjoint of the determinant A is obtained by these two numbers. You interchange. 4 becomes A11, 2 becomes A22. Okay. And this 3 and 1 you keep as such and just change the sign. So actually the formula is adjoint of a matrix is obtained as cofactor of the matrix A the whole transpose. Cofactor of the matrix A the whole transpose. Cofactor. So cofactor means interchange the rows and columns. So here, if it is a 2 by 2 determinant, easily we can write the adjoint of the matrix by interchanging A11, A22, keep these two as such, change the sign. Now let me give you an example, a 2 by 2. It is equal to 4 minus 1, 6, matrix, it is a matrix, minus 8. What is the adjoint of the matrix A? Now, depending on the question, you have to answer it. Like if it is a 1 mark question, you can just write down adjoint of A is equal to, what have you to do? Interchange these two. That is minus 8, 4. These two as such. But what have you to do is change the sign. So minus 1 becomes plus 1, 6 becomes minus 6. This is how you find the adjoint of a matrix. So adjoint of a matrix is cofactor of the matrix A the whole transpose. But if it is a 3 by 3 matrix, there is no other way to find the adjoint of the matrix. First you have to find the cofactor of the matrix, find the transpose, then you get what is known as the adjoint of the matrix A. I hope you are writing with me. Let us consider a 3 by 3 matrix or a 3 by 3 determinant. From a 3 by 3 matrix, you can get a 3 by 3 determinant, and you can find out what is the value of the adjoint. A is equal to matrix 1, 3, 3, 1, 4, 3, 1, 3, 4. Now it is a 3 by 3 matrix. Verify A into adjoint of A is equal to determinant of A into I, where I is a identity matrix. Verify A into adjoint of A. So A is given, adjoint of A. What is adjoint of A? Adjoint of A is equal to cofactor of A the whole transpose. So in order to find cofactor of A, you have to get the minus and cofactors. Minus, first you should get minus, and then from that you will get the cofactors. Here on the RHS it is determinant of A into I. Now let us find the cofactors. So first thing we are going to find out the minus M11. What is it M11? first row, first column. You are eliminating first row, first column. What is the determinant you are getting? 16 minus 9. 16 minus 9 is equal to 7. M12. First row, second column. You are getting 4 minus 3 is equal to 1. Be careful when you are doing the calculation because a small error can change all the values. M13 is equal to first row, third column. It will be 3 minus 4. 3 minus 4 is equal to minus 1. Now comes M21. M21 is equal to second row, first column. That will be 12 minus 9. 12 minus 9 is equal to 3. M22. M22. Second row, second column. That will be 4 minus 3. 4 minus 3 is equal to 1. Next comes M23. That is second row, third column. That will be 3 minus 3 is equal to 0. Okay. Now you can do the other three values. Do along with me. M31. M31. That is eliminating third row, first column. 9 minus 12. Minus 3. M32. I will write here itself. M32. That is third row, second column. Third row, second column. It will be 4, third row. That is 3 minus 3. And M33 is equal to third row, third column. It is 4 minus 3. Minus 3 is equal to 1. Minus. Let me check the values. 7, 1, minus 1, 3, 1, 0, minus 3, 0, 1. Okay. So from this minus, you can get the cofactors. Cofactors. Cofactors A11 is equal to minus 1 raised to 1 plus 1, the suffix, into M11. Minus 1 raised to 1 plus 1 is positive. Here it is positive. So it is equal to 7. A12 is equal to minus 1 raised to 1 plus 2 into M12. Minus 1 raised to 1 plus 2 is negative of 1. So negative of 1 is equal to negative 1. A13 is equal to minus 1 raised to 1 plus 3 M13. Minus 1 raised to 1 plus 3 is 4. That is positive. So this becomes positive into negative is equal to negative 1. Next one, A21. Minus 1 raised to 2 plus 1 into M21. Minus 1 raised to 2 plus 1 is negative. M21 is equal to 3. So negative 1 into 3 is equal to negative 3. A22 is equal to minus 1 raised to 2 plus 2 into M22 is equal to minus 1 raised to 2 plus 2 is positive. M22 is 1. So that is equal to 1. A23 is equal to minus 1 raised to 2 plus 3 into M23. Minus 1 raised to 2 plus 3 is negative. M23 is 0. So the answer is equal to 0. A31. Minus 1 raised to 3 plus 1 into M31. So this is positive. M31 is negative 3. So this is negative 3. A32 is equal to minus 1 raised to 3 plus 2 into m32. Minus 1 raised to 3 plus 2 is 5. So that is negative. m32 is equal to 0. m33, a33 is equal to minus 1 raised to 3 plus 3 into m33. Minus 1 raised to 3 plus 3 is 6. So positive, this is equal to 1. So you have got the minors and cofactors. Now what is adjoint of A? Now I am going to rub the left hand side. What is adjoint of A? Adjoint of A is equal to cofactors of A, the whole transpose. So here you have the cofactors. Adjoint of A is equal to cofactor of A, which is 7 minus 1 minus 1 minus 3 1 0 A31 minus 3 0 1, the whole transpose. Okay, tell me, how do you get the transpose? Yes, interchange the rows and columns. 7 minus 1 minus 1 minus 3 1 0 minus 3 0 1. So verify A into adjoint of A. Next thing, you have to find A into adjoint of A. I hope all of you have done the RHS side. A into adjoint of A. LHS, A into adjoint of A is equal to 1 3 3 1 4 3 1 3 4 into adjoint of A. 7 minus 3 minus 3 minus 1 1 0 minus 1 0 1. I hope you remember how to multiply two matrices. How to multiply the two matrices? Row, column, row, column. It goes like a 7 pattern. Row, column, row, column, row, column. So let us see what is the answer is equal to. First row into the first column. So 1 into 7, 7 plus 3 into minus 1, minus 3 plus 3 into minus 1 is minus 3. First row into the second column, minus 3 plus 3 plus 0. Next one, minus 3 plus 0 plus 3. Okay. Next one, 1 into 7, 7 plus minus 4 plus minus 3. Next one, 1 into minus 3 plus 4 plus 0. Next one, minus 3 plus 0 plus 3. What about the last one? 1 into 7, 7 plus minus 3 plus minus 4. Next one, minus 3 plus 3 plus 0. Minus 3 plus 0 plus 4. Okay, and that is equal to matrix 3 minus 3 minus 3 minus 6, 6 plus 7, minus 6 plus 7, 1. Here it is 0. Here it is 0. Here it is minus 7 plus 7, 0. Here it is 1. Here it is 0. Here it is 0. This one 0. This one 1. So you are getting an identity matrix of order 3. This is the LHS. Verify A into adjoint of A. Now we have to consider RHS. This verification type of questions is very important because you should know each and everything. A into adjoint of A. So here it comes two things. Multiplication, adjoint of a matrix. Adjoint is cofactor transpose. Here another property, determinant of A. Then I. What is I? Identity matrix. What is determinant of A? So determinant of this matrix A is equal to determinant 1, 3, 3, 1, 4, 3, 1, 3, 4 equal to 1 into 16 minus 9. Then at once you put the minus sign. Minus 3 into 4 minus 3 plus 3 into 3 minus 4. 16 minus 9 is equal to 1 into 7 minus 3 into 1 plus 3 into minus 1 equal to 7 minus 3 minus 3 is equal to 1. But our right hand side is not yet over. It is, I hope you completed the first row. RHS, determinant of A into I is equal to, what is the value of determinant of A? 1. 1 into I. I is 1, 0, 0, 0, 1, 0, 0, 0, 1. So 1 into means a scalar multiplication. Each element is multiplied. That is 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, so what have you got the result? Therefore, A into adjoint of A is equal to determinant of A into I. Verified. This is a property. A into adjoint of A is equal to determinant of A into I. If you skip a positive sign or a negative sign, you won't know where you have gone wrong, whether the LHS or the RHS. So be careful when you multiply all the steps. Clear? Nothing new. All these things we know already. We are just applying it. Okay. Now, let us consider another example. Next one. Take the property. If the elements of a row or column are multiplied with cofactors of any other row or column, then their sum is 0. If the elements of a row or column are multiplied with the cofactors of any other row or column, then their sum is 0. If the elements of a row or column are multiplied with the cofactors of any other row or column, then their sum is 0. That means elements are denoted by A11, A12, A13 or A21, A22. Small letters you are using for elements. If the elements of a row, so these are rows. or column we can take are multiplied with the cofactors of any other row or column. Suppose if I am taking second row, first row, second row. What about the cofactors of the second row? Cofactors of the second row is denoted by A21, A22, A23. I hope you are getting it. Once again, if the elements of a row or column of a matrix are multiplied with the cofactors of any other row or column. So, elements, first row, is multiplied by cofactors of any other row. Cofactors of any other row. So, row means row should come, column means column should come. So, since I have taken row, here I should get row A21 plus, then their sum. So, plus A12 into A22 plus A13 into A23 is equal to 0. This is the property. Once again, if the elements, it's an important property. Second row. But the elements are taken from the first row. Elements are taken from the first row, but the cofactors are taken from the second row. Okay. Third row can also be taken. But when you take row, the cofactors should be of row. If you take column, cofactors of the column corresponding, cofactors of the column should be taken. Let us consider one example. This is an important property because question may come like this. Fill in the blanks or any other type of questions you may be asked to do. So, be careful with the question. Take down the question. Using cofactors of the second row. Using cofactors of the second row. Cofactors of second row. Find the determinant. The symbolic notation is given. So, determinant is equal to, the determinant is 5, 3, 8, 2, 0, 1, 1, 2, 3. So, they are specified cofactors of the second row. So, determinant, cofactors of the second row. Find the determinant, value of the determinant. So, cofactors of the second row means, what are the values notation? A21, A22, A23. A23. So, before getting the cofactors, you should know what are the minors. Minors. M21. M21. So, M21 means eliminate the row containing second row and the first column. So, it will be 9 minus 16. 9 minus 16 is equal to minus 7. M22 is equal to second row, second column. It will be 15 minus 8. 15 minus 8 is equal to 7. M23 is equal to second row, third column. 10 minus 3. 10 minus 3 is equal to 7. So, what is A21 is equal to? A21 is equal to minus 1 raised to 2 plus 1 into minus 7. This is equal to, this is minus of minus plus 7. A22 minus 1 raised to 2 plus 2 into M22, 7. Positive of positive, positive. A23 minus 1 raised to 2 plus 3 into M23. It is equal to 7. So, this is negative. This becomes negative 7. Okay. Using cofactors of the second row. So, I will take second row and I am going to take any other row if the elements of the row are multiplied with any other row or column. So, I am going to take the first row elements. Let this be the step. A11 into A21 plus A12 into A22 plus A13 into A33. According to the theorem, what should be the answer? The answer should be equal to 0. Let us check. A11 is equal to 5 into A21, 7 plus 3 into 7 plus 8 into minus 7. 5 into 7, 35 plus 21 plus minus 56 is equal to 35 plus 21 is 56 plus minus 56 is equal to 0. So this is a property. I hope you got it. If the elements of a row or column are multiplied with the cofactors of any other row or column.
Using cofactors of second row, find determinant.
Find the determinant. So what is the determinant value? Determinant value is equal to find the determinant value. I have given you the question. Find the using cofactors of second row. So I used cofactors of the second row. Find the determinant. So according to the theorem, this determinant value will always be equal to 0. So I have proved it. I have used the cofactors of the second row elements from the first row, and I have proved that equal to 0. So this is a very important question. Now next one. Suppose you may get a simple question as find, I will write on the board, find the minor of the element 6. Minor of the element 6 in determinant 1, 2, 3, 4, 5, 6, 7, 8, 9. Minor of the element 6. Or one more thing can be asked, minor and cofactor of the element 6. So you are finding out 6. That means minor means it is denoted by M. Where is the position? M, 2, 3. Second row, third column. So what you will do is you eliminate the second row and the third column because it contains 6. Second row, third column. That is equal to 8 minus 14, which is equal to minus 6. Just that value. So it is a one word question. Along with it, cofactors can also be asked. So what is cofactor? A23 is equal to minus 1 raised to 2 plus 3 into M23. This is negative. Negative of negative 6 is equal to positive 6. It's a 3 by 3. Another example with 2 by 2. 4 minus 3, 2, 6. Find the minor of the element 4. Find minor and cofactor. Cofactor of element 4. Element 4. Here it is easy because it is a 2 by 2 determinant. Minor 4. Element 4. Eliminate that row and column. It is equal to 6. So what is the notation? A or M11. What is a cofactor? Is equal to minus 1 raised to 1 plus 1 into M11. 1 plus 1, 2. So minus 1 raised to 1 plus 1 is positive, and that is also equal to 6. So this is minors and cofactors. Now I'll give you a short break. Just go through the examples and we will continue with the next topic.